Hello, everyone. Welcome to our discussion for the second most common cost segregation technique, which is scattergraph method. The objective for today's discussion is to define and understand the concept of scattergraph method, and we should be able to solve the illustrative example using this method. Scatter graph or visual fit analysis shows the observation on a graph, gives a chance to make an analysis on the plotted observation, and draws conclusion on the relationship between the y, which later on when we graph the illustrative example, y stands for the cost and x-axis will be the base or the variable. This method uses the principles found in a regression line which depicts the relationship of two variables, the x and the y, being x is the independent variable and the other is the dependent variable. A regression line is normally expressed in the equation y is equal to a plus bx. The y here is the dependent variable or the value which we should determine. A stands for the constant or the point of intercept. B here is the variable coefficient of x or which sometimes called slope. And the x here is the independent variable which is normally a given value. This equation is a perfect resemblance of the total cost where if you will going to recall our previous discussion on this one, the total cost is the summation of the fixed cost plus the variable cost, wherein the total cost is also equal to the total fixed cost plus the variable cost rate multiplied by units sold. In this case, if we're going to translate it to the equation, our total cost here is the y, a is the total fixed cost, and the b multiplied by x is our total variable cost. Let us try to solve the illustrative example. The total mixed cost of ABC Company for the year 20x1 are as follows. We have here the month from January to December, so that's basically 12 months. Then our cost driver here or our basis here will be the shipments, and we have here the column for the total cost. The requirements are we should be able to compute for the variable cost rate, total fixed cost, and we should be able to express the line of regression. The first step, if we are doing our line of regression, is to draw the x or the horizontal axis and the y-axis in the graph. Let our y-axis be the cost. Then with this, we should be able to scale our graph. Since the total cost here is 45, 52, 70, and the highest here will be 70, then let's try to scale our graph by multiples of 10,000. Let's start with highest 80,000, then 70, 60, 50, 40, 30, 20,000, 10,000, and 0. Let's now try to scale the x-axis. Let's go back to the given. So here, our highest is 90. Then our lowest here is 40. Then let's try to scale our graph by multiples of 10. Here, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Now that we have our graph here, so again, the x-axis will be the units, then the y-axis will be the cost, then step number 2 is to plot the coordinates. Let's go back to the given. For the month of January, it's 50 and 45, February, 60 and 52,000, and so on. So for the month of January, we have here 50, then 50 for the x-axis, then y-axis is 45. So let's use red ink. So 50, then 45, so it's here. February, 60 and 52. 60 and 52, so let's just approximate the 52 here. Then March is 90, then 70. Okay, so let's try to zoom it in. April, 70 and 55. May, it's 40 and 37. It's above the middle of 30 and 40,000. June, 60 and 58. 60, then a little bit above the middle of 50 and 60. July, 45 and 45. So August, 55 and 54. September, 65 and 50. October, 80 and 60. November, 75 and 58. And lastly, December, 70 and 60,000. If you're going to notice here, the areas shaded in orange are called clusters. Then the next step that you have to do is draw a straight line in the middle of the plotted observation following the depicted relationship between x and y, where the total difference of the points above is equal to the differences on the points below the line. In this case, we should be able to draw a straight line wherein there will be 6 dotted points above and 6 dotted points below. Now, this will be our line of regression here. If we're going to count for the division of the plotted data, so we're going to count here 1, 2, 3, 4, 5, 6. So basically, we can have a confidence that this line, which has an intercept in 20,000 pesos, that will be our line of regression. Now let's have here the markings. So the 20,000 here will become our A. So basically, if you're going to be asked, how much is the value of your total fixed cost? Answer here, TFC is equal to 20,000 pesos. So to answer the second requirement, this is 20,000 pesos. Let's go back to our graph. After determining the value of A or the value of the total fixed cost, then labeling this line, this yellow line, as our equation, y is equal to A plus bx, then we have to compute for the value of B or the variable cost rate. To do this, we have to optionally choose 2 points. So in this case, we will going to choose this point, the area for the orange field here, the maximum amount is 60. Okay. Then this will be our highest point. Then the lowest amount here is above 35,000. So this point. The coordinates of the lowest point is, let's try to approximate things. So this is between 35 and 40. So let's try to make it 37.5. Then the y-axis is 40,000. Then let's try to locate the coordinates for the highest point. So the coordinates of the highest point here is 75 and 60,000 pesos. Okay. So this will be our change in y and change in x. Then let's try to get the highest and lowest method. So to do this, we have here the change in y is equal to the change in x. So basically, what we're going to do here, since b is the slope, remember that the change of y and change of x is similar to rise over run. Either of the two will give you the exactly the same answer because both of these are the formula for the slope. For the change in y, that will be 60,000 less 40,000. Then for the change of x, which is the run, that will be 75 less 37.5. That will give us 20,000 for the numerator, then 37.5 for the denominator. Then our b here is equal to 20,000 divided by 37.5. That will give us 533.33 Now, this will be our variable cost per unit. So let's try to go back to the requirement. The first requirement here, this will be 533.33. Now that we have the variable cost rate, then we have the total fixed cost. We can now get the regression equation or the linear equation, and that will be y is equal to the value of the total fixed cost, 20,000, plus the value of the variable cost rate, 533.33, then x, because x here is always a given. With this equation, then, at any level, for as long as it is within the relevant range, you will use this formula. For example, we have here a shipment of 68. Then we should be able to use this formula as the total cost is equal to 20,000 plus 533.33 multiplied by 68 shipments. That will give us the total fixed cost will still remain constant because it is within the relevant range, 20,000 plus 36,266.44. Our total cost, if the shipment is at the level of 68, is equal to 56,266.44. If you are an aspiring CPA and you will going to take the CPA board exam, because the CPA board exam is a manual type of exam, then you should not be able to use any sort of automation on this one. So that's why it's very important to know how to compute for the line of regression if there will be a series of data points given to you. So the most important thing here is that you should be able to scale properly your graph. Again, y-axis will be your total cost and your x-axis here will be your units or the basis of the level of activity. Then use the clustering. Then see to it that when you draw the line, the half of the line is above, then the other half is below the line for you to exactly pinpoint what is the correct amount of your point of intercept or what is the exact amount of your total fixed cost. Then if you're going to choose for the 2 points, see to it that it is within the cluster or within the shaded area. If you're going to compute for the variable cost rate, see to it that you will going to use the high-low method or the formula or the algebraic formula for the slope, which is rise over run, or change in y divided by the change in x. That's the end of our lecture video for the scatter graph method. Thank you all for watching.